So this is it, the last topic for your third quarter exam. The Chemical Kinetics Lesson 4. Let us discuss the handouts. The rate of chemical reaction. In 1864, Peter Wage and Cato Maximilian Goldberg, both Norwegian chemists, shown on figure 4.1, ito sila, si Peter Wage and Cato Maximilian Goldberg, pioneered the development of chemical kinetics through the law of mass action, which states that the speed of a chemical reaction is proportional to the quantity of the reacting substances. Mathematically, it states that the rate of a chemical reaction is proportional to the product of the masses, concentrations of the reacting substances. Ito siya, reactant and the product. So, the rate of a chemical reaction is proportional sa product ng ating mga product, okay? When we say product, that is multiplication. Product of our concentrations ng ating reacting substances. And this is the mathematical expression of that statement. Rate of a chemical reaction R is equals to K, that is a rate constant, and concentration of our reactant A to the power of its mole A times the concentration of our reactant B to the power of their mole. Okay? Yan siya. Rate equation is a mathematical representation that describes and visualizes the behavior of solution in dynamic equilibrium. Topic: factors that influence reaction rate. So there are factors that influences a reaction rate. For example, this chemical equation is hydrochloric acid will decomposes to hydrogen and chlorine. When we say decomposing, maghihiwalay yung dalawang element, hydrogen and chlorine, into separate elements from one compound to individual element compound or elemental compound. HCl, since 2 moles kasi, balance equation na ito. 2 hydrogen, 2 hydrogen. 2 chlorine, 2 chlorine. So, this is a balanced chemical equation. When these are decomposing, the reactant will slowly separate from each other and then it will form a new bond that is related to them. Ayan, si HH and chlorine-chlorine. And sa product is, ito na sila. So, from one compound to new individual elements or individual compound. And what is chemical kinetics? It is the study of the reaction mechanism and rates of chemical reaction. What is reaction mechanism? It is characterized by the breaking of old bonds and formation of new bonds. It is also defined as a temporary stage characterized by breaking of old bonds and formation of new bonds. Ito na siya. Explain ko kanina, from old bonds to a new bonds. That is a reaction mechanism. If in a reaction mechanism, the old bonds are broken while new bonds are formed, as shown in figure 4.2, the rate of chemical reaction shows how fast and how far the reaction proceeds. So, yung ating chemical reaction only predicts the reaction rate of decomposing nitong chemical natin na HCl. Let us look at the reactions: roasting of piece of metal made of iron and the combustion of butane gas. We know that both reactions take place and both are completed. The roasting of iron takes years to complete but butane burns immediately. So, sa kaibahan sa the reaction rates of the roasting of iron is much longer than the reaction rate of burning the butane gas. Moreover, the iron will rust faster when it is wet and faster in the presence of more oxygen. These are one of the factors that increases the rate of reaction when the iron is wet and when it is exposed to more oxygen. Obviously, there are factors that affect the rates of chemical reaction. Namely, first is concentration of reacting substances, second is pressure, and the third is temperature. When the factors is about the concentration of reacting substances, it is the most noticeable factor that affects the rate of a chemical reaction. As the concentration of any or both of the reactants are increased, the rate at which these substances react also increase. This behavior of these substances as their concentration are increased is explained by the collision theory. This means that the higher the concentrations, more particles or more molecules are present in the system. Therefore, there is greater contact between the reacting particles, or there is more collision, thus the chemical reaction is faster. And when we say pressure in a chemical reaction involving gaseous reactant is kapag yung ating reactant is gaseous, it is very pressure is very involved in the reaction rate, because the partial pressure of each gas has the same purpose or role as the concentration. This means that if the overall pressure of the reacting substances is increased, the rate of chemical reaction also increases. This is also true when you decrease the volume of the reacting substances. An increase in pressure causes the particles to collide with greater forces, thus more collision is in effect and products will be formed faster. Last is the temperature. And when you studied gases, you learned that as the temperature is directly proportional to kinetic energy, meaning increasing the temperature, the molecules bump each other more forcefully, making more collision, thus increasing the rate of chemical reaction. Next topic is the rate law and its components. As mentioned in the introduction, the rate of a chemical reaction is the product of the concentration of the reacting substances. Each concentration is raised on exponents that are determined experimentally. Mathematically, given the chemical equation, mole A, reactant A, gives mole B, reactant B. That is nagkapalitan. The rate equation shall be R equals constant K times the concentration of the A, the power of its mole. Okay. This power also is also termed as order of rate equation. Order of rate equation. It is with respect to a given substance defined as an index or exponent to which its concentration term in the rate equation is raised. So the number of the mole here will dictate the order of rate equation. Again, given this equation, two reactants A and B will give two products C and D. And again, rate of the reaction is equals to K constant times the concentration of our A raised to its mole times the concentration of B raised to its mole. So, order of rate of equation is dependent sa malaki yung power. So, if ever ito si A is 2 and this is 1, the order of rate of this equation is second order. From the given examples, you will notice that the rate equation is dependent on the concentration of the reacting substances. Thus, rate law is expressed in terms of the concentrations or pressure of the reacting substances. Example 1. Ayan, ito na siya yung kanina. Hydrogen chloride gives hydrogen gas and chlorine gas. What is the rate equation of the chemical reaction? Simply, rate equation is equals to R equals K, and open and close bracket, HCl raised to the power of 2. Bakit 2? Dahil 2 moles. Okay, yan yung answer sa question A. Question B, given the following data, rate constant K, 1.8 per molar second, determine the rate equation of the above chemical reaction. Dito, binigyan lang tayo. We have just given the value of K, and we need to input that. The answer is R equals 1.8 per molar second times to the concentration of HCl raised to 2. That is the answer. At what rate does 1.35 molar HCl be decomposed to hydrogen and fluorine gas? The letter C, we have given a concentration in a molar concentration of HCl. Now, the answer is R equals 1.8 over molar second times 1.25 molar to the power of 2. And that is equals to 2.81 molar per second. Dalawang molar dito, cancel this one. Matitira isang molar and second. So that is molar per second. This means that 1.25 molar HCl decomposes at the rate of 2.18 molar per seconds. Next, the collision theory. It explains that gas-phase chemical reaction occur when molecules collide with sufficient kinetic energy. The collision theory is based on the kinetic theory of gases. Therefore, only dealing with gas-phase chemical reactions are dealt with. So, sa collision theory, it is only applicable in a gas-phase chemical reactions. Ideal gas assumptions are applied. And furthermore, we also assume that all molecules are traveling through space in a straight line. Okay, that is about gas phase. Second, all molecules are rigid spheres. Third, the reactions concerned are between only two molecules. And fourth, the molecules need to collide. Ultimately, the collision theory of gases gives the rate constant for bimolecular gas phase reaction. It is equal to the rate of successful collision. The rate of successful collisions is proportional to the fraction of successful collisions multiplied by the overall collision frequency. Okay, we will not further elaborate this. Let's go to the catalysis. Catalyst is a substance that increases or decreases the rate of a chemical reaction without in itself undergoing a permanent chemical change. So, a catalyst is only there to increase or decrease a chemical reaction, but it will not undergo a chemical change together with the chemical compounds. Okay? The catalyst decreases the activation energy, thus causing the rate faster. There are two types of catalysts, namely the promoter and inhibitor. When we say promoter or a positive catalyst, it is a substance that increases the rate of chemical reaction since it decreases the activation energy, as shown on figure 4.3. Pag walang activation energy, pag walang catalyst, this is the reactant, and when they undergo a chemical reaction, it forms product. When we have a reactant that has no catalyst present, the activation energy without catalyst, this blue curve here, is very wide. Okay? The higher the energy is needed to activate or to for the reactants to produce product. But when a catalyst is present, it will decrease the energy needed for that reactants to proceed to product. That's the essence of a catalyst. Next is enzymes that are present in the human body are examples of catalysts like pepsin in our digestive system. It is a digestive enzyme that breaks down protein into absorbable substances. Inhibitor or negative catalyst. This one is a substance that decreases the rate of chemical reaction since it increases the activation energy. Okay? Phosphoric acid can be used to retard the decomposition of hydrogen peroxide. So, here, this example is about the effect of a catalyst in a chemical reaction. So let's talk about example 2. The decomposition of hydrogen chloride gas is a second degree reaction if the rate constant is 0.125 molar per molar second. How fast will a 0.4 molar HCl is used? So ito na. Given na tayo lahat. The second degree, that's the power. The rate, that's the K, rate constant K, and the concentration of HCl. Ayan. So, R is equals to K times the concentration HCl to the power of 2. Inputting the information, we can get 0.02 molar per second. Next, example 3, ammonium gas decomposes to nitrogen gas and hydrogen gas. And this is a balanced chemical equation. Given tayo nito, the concentration of our NH3 unit is molar, and the rate of equation is R, na molar per second, that is 0.032 or and 0.0550. Ito siya, 0.2 concentration is, ang R niya is 0.032. And the 0.25 concentration of NH3, ang R niya is 0.05. But from that data alone, we can get what is asked. Question. Sorry. The following data is obtained in the decomposition of ammonia gas, NH3. Determine the order of the reaction, the rate constant, and the rate equation. So the answer to letter A is the order of the chemical reaction is 2. Bakit 2? Dahil 2 mole. Okay, that is why. So from the above data, we can get the rate constant, that is K. By using equation 1, by using the equation of R equals K times the concentration of the reactant to the power of its order, or the mole, we can input each R na 0.032 equals K times the concentration of 0.2 to the power of 2. That is equation 1 for this problem only. And another R, 0.05 equals K times 0.25 to the power of 2. Another equation. So, solve either of the equation. Pili ka, either equation 1 or equation 2 to know the value of K, or the rate constant. So, we choose equation 1. For equation 1, we get the K by simply doing this expression na 0.032 molar per second all over 0.2 molar to the power of 2. Okay? K, now the rate constant K is 0.8 per molar second. That is the unit of rate constant. Now, the last question is the rate equation. So, the rate equation is equals to R equals K concentration to the power of order. Nilagay ko lang yun lahat, inputting all the information to get this equation, rate of equation. Next, answer to B. What is the rate of decomposition of 0.4 molar ammonia? Now we have a concentration na for our ammonia. So from this rate equation, we need to input the 0.4 molar to the power of 2. Now the rate of equation is equals to 0.128 molar per second. Next question, what is the concentration of ammonia used if the rate of decomposition is 0.072 molar per second? Here, we were given the rate of decomposition, the R, 0.072 molar per second, and and what is asked is the concentration of ammonia. So we need to use the R equals K times the concentration of ammonia to the power of 2. Now, we need to input the given R na 0.072 molar per second and also the K, our K here. So we just use this rate equation here, just that the R is given. Now, the concentration of ammonia is the one we are looking for. By doing mathematical equation, we can get NH3 to the power of 2 equals 0.092 molar squared. To cancel that squared, we need to squared both sides, okay? To cancel the square of each equation or of each mathematical value. Now, we only get NH3 concentration is equals to 0.30 molar. Thank you for listening. This is all for our lesson 4 and good luck to your third quarter exam. I hope that you understood and you understand my discussion. If you have questions, you may PM me and you may comment. So thank you for listening. STEM 12. Good luck.